Hello students, so now we are going to solve one problem, and that is a problem from IIT JAM 2021. It is just a 1 mark MCQ problem, and this problem is from Kepler's potential or central force chapter. So the problem is very interesting. It is given there is a high eccentric orbit whose the closest approach of the planet and star is let's say RC, and the farthest approach of the planet and the star is, let's say, RF, and the ratio of RC versus RF or RF versus RC is given. So what is this problem? So obviously it is a elliptical orbit. So elliptical orbit is there. I can assume there is some star is there, and maybe this is my closest approach, and this is my farthest approach. I can assume this point of planet A is the closest point from our star, and here is our planet. Let's say assume the mass of planet is m, and this is farthest point. So let us go for this point is B, and it is given that RF by RC is equal to nothing but 300. So what we have to do, we have to calculate actually ratio between VC upon VF. So VC upon VF is all about ratio of speed at the closest approach to the farthest approach. So obviously we should go for conservation of angular momentum, because the forces are central, and whenever our forces are central, we can easily use conservation of angular momentum because your momentum is conserved. And we can also assume that motion is confined into plane. This all thing we can discuss in our theory, but here we can easily use conservation of angular momentum. So momentum at A, that is angular momentum at A, is equal to angular momentum at B. And if we are going to write the value of angular momentum at A, then this will be m. VC is the speed of planet at A, and RC is the distance of planet and star, and this is equal to m VF, that is speed of planet from farthest distance to star, and RF is the distance, farthest distance from planet from B to, let's say, the point of where a star is there. So this is all about conservation of angular momentum, and we can also assume that at this point this VC is exactly making 90 degree with RC, because these 2 points are also identified as turning points. So exactly it will be 90 degree of VF. And when we are going to calculate this thing, this is mass of planet, so this will be cancelled out. We have to calculate VC upon VF, and that value is nothing but RF upon RC, and this value is given, that is 300. So the VC upon VF is given as 300. So it's a quite simple question, 1 mark question, but yes, we have to keep in focus that angular momentum in a central force problem is always conserved, and we can easily use it as the farthest distance and as the closest distance, because there are only one component of velocity is there, that is tangential velocity, and we can get this, we can easily solve this type of problem. Thank you.